How much time would you want to spend on Voyager 1? Yes, in fact, the ancient probe has done it again, and once more proven that despite all the complications, it is still a reliable outpost in the mysterious world of interstellar space. This was preceded by an event that has almost become part of NASA's daily routine. The experts had lost contact with Voyager due to technical problems, and this was not the first time they had been forced to find creative solutions to restore contact with the aging spacecraft. Ultimately, the path to success LED through a component that had actually been obsolete for decades, and yet the backup transmitter, which had not been used since 1981, worked as desired and allowed the space veteran to phone home again. When it's cold outside, it's a good idea to turn on the heating. So far, so obvious, but it gets a little trickier when the temperatures in the depths of interstellar space need to be turned up and on. A spacecraft that has been traveling through space for almost 50 years and has repeatedly attracted attention for its technical ailments, and so it happened that what should have been a routine task once again led to an unforeseen Voyager 1 problem after NASA experts had given the spacecraft the command to activate one of its heaters on October 16th. They were perplexed to discover 2 days later that the Deep Space Network could no longer detect for Voyager 1's signal. The fact that the researchers had to wait 46 hours before this unwelcome realization reached them is again due to the immense distance that now exists between Voyager 1 and our earthly home. Specifically, since 1977, the probe has been separated from Earth by about 24.7 billion kilometers, and it takes almost 23 hours for a message to bridge that enormous distance. The same period of time is therefore also estimated for the response. But what actually happened? Well, Voyager 1 is basically equipped with an onboard error protection system that reacts independently to problems. This is the case, for example, when the spacecraft's power supply is overloaded and the error protection system switches off systems that are not absolutely necessary for the spacecraft to operate in order to save energy. But apparently the aforementioned heating command also triggered the error protection system, even though Voyager 1 actually had enough energy to activate this component. For a better understanding, it should be briefly mentioned at this point that Voyager 1 normally communicates with Earth via a so-called X-band radio transmitter named after its specific frequency, and following the loss of contact, the experts correctly assumed that the error protection system had reduced the rate at which the corresponding transmitter sent its data back. This is not surprising since this mode consumes less energy, but unfortunately, it also changes the XAND signal that the Deep Space Network has to search for. Fortunately, NASA engineers were able to identify the signal of desire on October 18th, and although Voyager 1 appeared to be in a stable state apart from that, the next problem was not long in coming: how a 40-year-old backup transmitter helped NASA out of a tight spot the next day. Communication with Voyager 1 actually broke down completely. The flight team suspected that the AOR-prone devil was lurking in the AOR Protect system again. It's possible that the system was triggered, again, by mistake switching off the XAND transmitter and instead switching to a second radio transmitter, the S-band. However, this had actually been in technical retirement for a long time. Although the SAND consumes less power than the X-band, Voyager 1 had not used it to exchange messages with Earth since 1981. A brief historical note: while Voyager 1 has now even passed the boundaries of the solar system, at the time, it had only just explored Saturn and its moons. Incidentally, 1981 was also the year in which U.S. President Ronald Reagan and Pope John Paul II were seriously injured in assassinations, and in which the current King Charles married a certain lady. Die back to the present. We can see why the S-band has been obsolete for 43 years. Despite all the energy-saving advantages, it uses a different frequency from the X-band transmitter and therefore has a significantly weaker signal. Given the enormous distance, the NASA experts were initially unsure whether they would even be able to detect the S-band, but they found it and then had to decide what steps to take next. However, in view of the error protection history, simply switching the XAND back on seemed too risky to them. This should only be done once the cause of the system being triggered has been clearly identified. However, past experience has shown us that such an error analysis can take weeks or even months. But does this now mean that contact with Voyager 1 will also be lost during this time? Well, luckily, not after all. There is still the S-band transmitter. On October 22nd, the experts sent a command to check whether it was still working properly, and lo and behold, on October 24th, the relieving answer came back that a stable connection had been re-established. So it turns out that NASA's backup transmitter, which has not been used in over 40 years, is now helping out of trouble maintaining contact with humanity's most remote outpost. But despite all the reawakened S-band transmitters, it's also undeniable that the journey to the edge of the solar system has now noticeably taken its toll on the probe's instruments, and that we may slowly but surely have come to terms with the idea that even the longest-lasting success story in space travel will eventually come to an end. How the life of the Voyager probes is being extended, but the time of farewell has not yet come, and that is the good news. However, it's also true that the members of the Voyager mission sometimes have to find creative solutions to extend the deployment of their sister probes, which are identical in construction, with regular certainty. But no one could have guessed in 1977 that it would ever come to this when the Voyager probe set out into the vastness of space. Back then, the predicted mission duration was just 5 years. The fact that the spacecraft have now exceeded this prediction by almost 10 times is partly due to the fact that they have since been put on a strict power diet. In other words, in order to save energy from the aging radionuclide batteries, NASA has systematically switched off more and more of its instruments. For example, the use of Voyager 2's plasma sensor has been a thing of the past for a few weeks now in order to be able to supply the remaining instruments with energy for a few years longer. However, this power-saving plan becomes somewhat tricky as soon as something unexpected happens, and if, for example, an essential nozzle fails to function. It may be that the terrestrial experts, the nozzle goes. But what had happened? In order for the Voyager probes to point their antennas in the direction of Earth and phone home in the best ET manner they have to position them using small positioning thrusters. These thrusters, fueled by liquid hydrogen, adjust the alignment in several bursts that last only a few milliseconds, and Voyager 1 originally had 3 sets of these mini thrusters, but with decades in space deposits also accumulated in the fuel lines, and NASA was forced to switch from the first to the second set of nozzles as early as 22 years ago in 2018. It finally switched to the third set of nozzles, which was actually intended for course correction, but unfortunately, this set also recently attracted attention due to so-called clogging, or, in other words, clogged lines, and in fact, the situation is even more serious in this case than in the previous ones. While the original diameter of the course correction nozzles was still 25 mm today, only 0.035 mm remain. For comparison, that's not even half the diameter of a human hair before the components finally give up the ghost. The experts decided to switch back to one of the 2 previous not-so-worn nozzle sets, but that's easier said than done. After all, Voyager 1 has hardly any energy left, despite all the power-saving measures, and any additional power consumption could in the worst case mean the failure of an indispensable system, and that is precisely the crux of the matter. In order for the alternative thruster set to be switched on again at all, it has to be preheated due to its depleted energy reserves. However, this is only possible if another system is deactivated for it. But which one? Persists lie the question, because in and of themselves, all the systems that are still running are actually indispensable. To make matters more complicated, the scientific instruments might not turn back on once they were powered down. And so it was that NASA scientists first withdrew for weeks to pore over their calculations and tests. At the end of this consultation phase, it was again concluded that switching off one of Voyager 1's main heating units posed the least risk on August 27th. The time had come. NASA carried out its risky jet change maneuver and was ultimately rewarded for its courage, because while the main heating unit was shut down for an hour, the nozzles heated up during this time, enabling Voyager 1 to aim back at Earth from then on. Well, at least for now, as mentioned, this set is also anything but brand new, but rather already has a history of clogged pipes, and at some point, no matter how sophisticated the nozzle tweaks, they will no longer help, because even if the Voyager 1 antenna is still pointing in the direction of Earth, experts assume that radio contact will be lost by 2136 at the latest, due to the ever-increasing distance, and our experts assume that your click contact will happen in a few moments due to the ever-shrinking distance to the subscribe button, so go ahead and click that subscribe button. Now, so you never miss a new video from us again, we'll see you soon.